Hello, everyone, and welcome to today's webcast, Managing Performance and Security with Splunk on your IBM mainframe. Before we begin, I'd like to review some quick housekeeping items. Today's webcast audio is streamed through your computer speakers. If you need technical assistance with the web interface or the audio, please reach out to us using the chat window, which is in the lower left-hand portion of the screen. The presentation is scheduled to last approximately 45 minutes, and we will be followed by a question and answer session. You can submit your questions at any time during the presentation using the chat window, and we will answer as many as possible at the end. If for some reason we don't get to your question, we will follow up with you via email. This webcast is also being recorded, and you will receive an email early next week with a link to the download for both the recording of the webcast and the slides that we're using to present. And we encourage you to share them with your colleagues who weren't able to make it today. Our presenter for today's event is Ed Halleck. Ed is the Director of Product Management for Ironstream at SyncSort, and he is a highly experienced information technology professional with a broad experience in software, product development, support, product management, marketing, and business development. We're also joined by John Rita, our VP of Customer Experience. John has been a member of the SyncSort team for nearly 3 decades, and John leads the support and services organization for SyncSort's mainframe product line with responsibility for customer service, technical support, and professional services. We have a great session today with a lot of content to cover, so I'll turn the floor over to Ed and we'll get started.
Well, thank you very much, Lauren. Good morning, good afternoon, good evening, wherever you may be. As Lauren said, I'm Ed Halleck, Director of Product Management, and thank you for taking the time to join this webinar today. What I'm going to cover in this 30, 45-minute session, and we'll leave some time for Q&A at the end, is, first of all, why Splunk for mainframe data and why SyncSort for mainframe data with Splunk. And let's talk about that a little bit. Let's talk about the challenges of getting mainframe data into Splunk, and then I want to introduce you to our Ironstream product. I'll walk you through some samples of the type of information that we can analyze and present and visualize through Splunk with Ironstream. And then I want to cover quickly what the latest release of Ironstream, which we announced just a couple weeks ago, contains, and then be happy to answer as many questions as we can possibly take at the end. So why Splunk? Splunk has experienced, I think, as a corporation and as an adoption technology, phenomenal growth over the last 10 years. In fact, they had their recent annual conference called .conf in Las Vegas a couple weeks ago and announced that they had achieved up to 10,000 customers worldwide. And the reason they've been able to do that is that they have built a very scalable platform that enables ingestion of enormous amounts of information, allows that information to be indexed very easily, and then has supplemented it really with some very unique and broad abilities to analyze that information and visualize that data, and visualize it in a very customized manner, a very flexible way to be able to take and construct dashboards and put information on those dashboards in the manner that an organization needs to see it, a business unit needs to see it, make it very relevant. And this has really, I think, been one of the fundamental challenges that we have had in the mainframe environment for a long, long time. I have worked in performance and availability management, and we've always had the capability to collect very detailed information, very vast amounts of information. But we really struggled with how do we analyze that data and how do we visualize that data simply and make it relevant to the business. And I think that's really the fundamental power of Splunk, and that is to be able to take machine data at a very high volume in different types from different locations and put together the capabilities whereby we can index that data, we can do ad hoc searches against it, we can report and analyze the way we want to report and analyze it, we can build some customized dashboards with it, and we can also include monitoring and alerting capabilities. So it really is a very strong platform for taking what started out really as simple log data and now has expanded to really encapsulate virtually any type of machine-created data and provide an organization with the capability to do what they want to do with it. So why mainframe data? Well, the mainframes aren't going away. I've been in this business for a long time, and I went through client-server technologies in the 90s and web technologies in the early 2000s, and all the chatter and the talk and the predictions about the mainframe was going to die and the mainframe was going to go away and was going to be replaced by client-server technologies and distributed platforms and more cost-effective servers. Hasn't happened, and it hasn't happened for a number of reasons. Fundamentally, that the cost of those platforms really wasn't any cheaper for most organizations. In fact, in a lot of cases, it ended up being 60% more when you factored in, the number of components and the full-time employee expenses and everything else related to them. That they didn't go and kill off the mainframe. So the dinosaur still lives, so to speak. And if we take a look at Fortune 500 companies today, 71% of them are still running an IBM ZOS mainframe. And the reason that they're still running those mainframes is they have been running them for decades, and they've been driving their business transactions through them on a daily basis. In some cases up to 30 billion transactions worldwide on a daily basis are getting driven through IBM mainframes. And the reason that that's happening is those applications are so dependent still on major technologies and major components of ZOS, things like CICS for transaction processing, DB2 for database transactions. So when you look at this, 25 of the top world banks and 9 of the top world's insurers, 23 of the top 25 U.S. retailers, all still running IBM mainframes, and that makes that data critical to the success of those organizations to be able to take that mainframe data and analyze it and fundamentally get the value out of it that they need to do and need to get to ensure that their business continues to function on an optimal basis. So why SyncSort to do this? You could ask yourself, there's companies that have been out there doing performance and availability management of data. And, SyncSort, you might think of us as a sort company, right? And we certainly have been in the mainframe business for a long time, over 40 years with our MFX sort technology. But the reason we decided to go down this path is that inherent in our DNA and inherent in our structure, we've always been about how do we get the most performance out of an IBM mainframe, whether that be with our sort technologies or whatever that we're going to bring to the market. And this has been for us, as we've evolved as a corporation, really becoming about not only sorting data, but how do we bring big iron to big data in mainframe environments. Fortunately for us today, half the mainframes worldwide are running SyncSort software. So we have a very large and loyal mainframe customer base, and it was a very natural progression for us to take and apply our expertise around sorting data, doing I/O as part of sort applications, everything we knew around really being able to handle data in a mainframe environment and not logically really translate that into the collection of mainframe data and pushing that mainframe data into Splunk. We've also had the benefit of, through acquisition and through some growth, to acquire some technologies that are very germane and applicable to bringing information into the mainframe platform via Ironstream and providing to Splunk. In particular, we have technology now around DB2 migration solutions, and we also have some real-time network management and security software. So again, we've got a very large global customer base, over 12,000 deployments in 85 countries worldwide, over 1,500 mainframe customers, and again, over half of the mainframes in the world run SyncSort technology. So we believe from a heritage perspective that we're very well positioned to do this. So what are some of the challenges with getting mainframe data into Splunk? So those of you that are very familiar with the mainframe data that's produced and collected in a ZOS environment, you'll understand that most of that data is in some ways obscure, binary, EBCDIC data. And how do we take those complex mainframe data structures, for example, SMF data, which are variable length records, very complex in nature, the definition of the data is in the record layout itself. How do we take that data and how do we expose it to an open systems technology like Splunk so that it's readily available and easy to use? And that's been a challenge that we took on and we solved in Ironstream, converting that EBCDIC and binary data into ASCII data that could be easily used as value data pairs. Then you take a look at the security issues, right? The information on a mainframe that organizations might want to expose today or prior to Ironstream with Splunk, the only way to expose those information was to give somebody access to the mainframe to get at that information. And unfortunately or fortunately, mainframes host a lot of mission-critical sensitive data. And we don't always want to give our end users access to that mainframe system. And so we had to look at how do we get to an environment where we could be more passive about getting that information to a platform where somebody could seek out the information that they needed, but not have to get connected to the mainframe in order to do that. And then there's cost involved, right? If we're going to take mainframe data and we're going to process that mainframe data and we're going to transform it and transport it into Splunk, it had to be done in a very cost-effective manner without interference to system throughput, do it in a very low overhead model. And then correlating the mainframe information events from other sources. How do we bring together, for example, syslog data, SMF performance data, security and network information, and correlate that all together? That's been a challenge. That's been a challenge in the mainframe environment for decades. We have had technology that have been very good at understanding silos of information, very good at deep diving into the ZOS operating system, very good at deep diving into CICS regions and looking at CICS transactions within a region, for example, very good at deep diving and analyzing what's happening within the storage infrastructure that's connected to a ZOS system. But a correlation of that information and the effect that it's been having on a business application has been a challenge for those technologies. They've been very good at deep diving, but we've been very weak at analyzation, correlation, and then again visualization of the information in a manner that's useful to the business. And this is why getting over these challenges of how do we get this data into Splunk, how do we do it cost effectively, and how do we make it from an operational perspective valuable to the organization has really been the fundamental drivers for building Ironstream and integrating Ironstream with Splunk. So what type of data do we capture with Ironstream? And this is just a sample, but we look at data from different really perspectives: security information, operational data around the effectiveness of IT operations, and also what's the type of information we need to collect to gather information around applications that we want to monitor, those applications that are critical to the success of the business. And so when we look at those functional areas, the different types of mainframe data that we collect are things like SMF records and a variety of different SMF records that we'll collect, syslog and syslog-D information around operational and security pieces of reporting. And then from an application monitoring perspective, we need to know what's happening with CICS. We need to know what's happening with DB2. We need to know what's happening with WebSphere, what's happening from a job step execution perspective. So a variety of SMF records, things like SMF 101 records related to DB2, SMF 110 records related to CICS, SMF Type 30 records related to job step execution, and Log4j information about what's happening in a web application environment. So we have taken a very simple, scalable, and efficient approach to this. We collect this critical mainframe log data, that, again, whether that's SMF records, syslog, syslog-d, log4j, even mainframe files. We do it in real time. We translate and transform that information and put it into a very simple data structure that's easily recognizable and usable by Splunk. Then we securely forward that information into Splunk so that it can be really utilized in Splunk applications, the Splunk Enterprise Security application, the Splunk Enterprise Overall application, about to roll out the Splunk IT Service Intelligence application, just securely forwarding that information, making it readily available to Splunk, and we can pretty much provide millions and billions of SMF records per day with a minimal impact to the mainframe as we do that, because it's a very low overhead collection technology that grabs the information at the point that the system's ready to record that information. Transformation's done on it, and it's sent via a secure TCP/IP connection directly to Splunk. So I've kind of almost jumped into this next slide already, but this is a very simplistic view of the architecture. It is a very simple architecture. Ironstream sits there. It collects information from things like SMF, Log4j data, syslog, whatever it may be, does a transformation of that information and quickly forwards that via an IP connection to Splunk. And once it's in Splunk, that information can be analyzed, visualized, presented in a manner that the organization would like to see it in. So I'm going to show you a few sample dashboards. This is actually a launch pad that we brought and introduced a couple weeks ago at the .conf conference that has in it 8 sample applications that we provide today to analyze and expose mainframe data. And I'm going to show you a few examples of these so you get an idea of the types of information that can be collected, analyzed, and displayed. So this first dashboard is a dashboard of information that's been collected from syslog data to show RACF violations and record trends. And it's pretty simplistic. We're showing RACF violations by type, RACF violations by users, and then we're showing the trend of critical message volumes from a point in time today and trending that against what happened a week ago and what happened 2 weeks ago. And if you take a look at the 3 pieces of information in this dashboard, in essence, each one of those 3 boxes represents a unique search and a unique report within Splunk. And the really nice thing about the technology is that you can take a search, you can have that search produce a graph like you see in one of these boxes, and you can drop that graph and that report in any dashboard. So this just gives you the flexibility really to construct and pull together the information in any manner that's relevant to the organization. Here's another simple one. This is just showing batch activity over time. And it's really the intent here is to show the peaks in the batch window, right? What's the time of day and what days of the week do we have the highest peaks? And not surprisingly, we see here that the peak is on Monday in the evening, right? That's probably typical in a lot of organizations that we'll see a peak at some point in time, a Monday evening peak, a Friday evening peak, maybe a weekend peak, whatever it may be. And then with Splunk, what you could do, and I don't have a sample of this, but we could just go now and we could click on that bar chart and we could drill down and we could actually see what are the 400 or 500 jobs that are running at that peak. And that's the beauty of Splunk. It just gives you the capability to do that very easily. So in talking about batch a little bit, and this is actually a job monitor we built for service level agreement tracking using SMF type 30 records. And what we did is we trended the information of batch job executions in the organization. And we looked at, based upon that trend, what kind of should the service levels be for individual jobs? When do they and when should they need to complete by? And then we set up basically thresholds for those jobs, and then we monitor the execution of them in real time to see, are they going to meet that service level agreement? And if they're not going to meet that service level agreement, we're either going to raise a yellow highlight to indicate a warning that potentially it may not meet it, or red indicating we definitely believe it's not going to meet its service level. And you have the capability then to drill down from an individual job and look at what's the predecessor jobs that are affecting the completion of this job and therefore affecting its ability to meet its service level. And that's just some of the things that you can do just with SMF type 30 records funneled by Ironstream into Splunk, and then using the Splunk technology to do the data analysis. This is a mainframe security dashboard that we put together. This is just showing invalid logon attempts, the rate of invalid logons, and then coupled with that, we're showing job initiations and tracking authentication successes and failures at the same time. If we think about security in most environments, today, every organization will tell you they're as secure as they believe they can be, but they're always faced with the feared inevitability of some type of threat or exposure happening, because you just can't tie it all down. As much as we'd like to, there's always something or someone out there that's going to make an attempt to hack or breach security within the infrastructure. And so by looking at patterns of failed logon attempts, the rate of logons or failed logons, and the tracking authentication successes and failures, we can look at patterns, and we can even look at what are the resources that the authentication failures are occurring against, and try to predict the potential for a threat that we might want to take a step back and put some additional security measures and protection around. This is one for monitoring DB2 performance. So again, taking the information that comes from SMF data and looking at, for example, what are the DB2 logging rates for DB2? What kind of uncommitted records are still out there based upon plans within DB2? What type of lock contention issues are we having, or lock state escalations that are occurring, and what are some of the unavailable resources within the DB2 environment? Trying to look at, again, the performance impacts to the DB2 environment. And again, each one of these 5 individual reports that have been pulled into this dashboard can be taken and utilized in other dashboards, put together with other information. These are just samples to demonstrate really the power that you have and what you can do with Ironstream coupled with Splunk. Another sample of CICS transaction monitoring, looking at transaction rates, transaction response time, CPU utilization by transaction, and then actual KIX transaction failures. And there's no reason, for example, that we couldn't pull together CICS transaction rates and transaction response times for a certain 5 or 10 critical transactions in the organization, and tie that to DB2 lock contention information, because in many cases we'll have a CICS transaction resulting in a call to a DB2 database. And so there's no reason we couldn't pull together information, reports that we're seeing with the searches being displayed in this dashboard with information that came from the DB2 dashboard in the previous example. So that's just kind of gave you a flavor of kind of the types of things that we can do and are doing today in sample applications that we provide with Ironstream to Splunk. So I want to talk a little bit about Ironstream 1.3. This is a new release. General availability was announced on September 23rd. And the major two pieces of this release were some new network security information provided via Zen technology. Now, Zen technology is network and security monitoring technology that SyncSort acquired when we did an acquisition of William Data Systems earlier this year. And what it does is really does a pretty significant monitoring of the ZOS network environment, very analogous to what you would do with something like NetView. So now we have that network information available, and we can, through Ironstream, funnel that information to Splunk and have the capability now to have mainframe security network insights exposed in both Splunk Enterprise and the Splunk app for enterprise security. We've also enhanced our SMF and log collection technologies, and this has kind of been our roadmap and our strategy all along. When we introduced Ironstream last year, we started with a subset of SMF data and syslog data with the full intention that we were going to continue to add SMF data types that were critical to the applications that we wanted to deliver, and at the same time we were taking customer requirements and prospect requirements for different SMF types of data and continuing to expand really the breadth of what we could collect and provide to Splunk. And again, this is really about making it easier to analyze, search, and visualize the information that might be related to, what's the end-to-end performance of an application in your operating environment, and how do you get better insight in terms of, how you're servicing both your internal end users as well as your external customers, so that we're seeing problems and you can see problems earlier and you can address those problems that are going to impact performance of your applications in your operational environment quicker. This is just to kind of give you an idea of where we started when we were GA with the product, and it was very simple back in the original GA in the middle of 2014. We started with just SMF type 30, SMF type 80, which was RACF records, SMF 110 records for CICS, Log4j, 1 data for web applications, and syslog data. And we have expanded on a quarterly basis since then, adding SMF record types, adding the ability to actually take batch files and also bring those into Splunk via Ironstream. We've just announced our capability with 1.3 to support network data. We're about to roll out a user API facility and support for RMF Monitor 3 real-time data. We're just going to roll out support for Unix System Services files as well. And then looking into 2016, we've got a plethora of additional SMF data types that we're going to do, some additional MQ data, some support for other flat files. Again, we're just continuing to grow the number of data sources that we're going to collect with Ironstream and bring into the Splunk environment for analysis. So the network and security data that we just added, again, this was added really through our acquisition of William Data Systems, leveraging Zen technology, but really we wanted to focus on intrusion detection and also look at monitoring the overall IP environment within the enterprise, looking at information from Enterprise Extender, looking at FTP information, bringing information in from the Open Systems adapter, and also collecting information about Linux, particularly about Linux running on System Z. And the reason that we did this and why it matters for Ironstream to bring this information into Splunk is it's really all about getting a handle on and understanding potential security attacks and events, and being able to start streamlining the investigation of security incidents, because we have to mitigate the risk of data breach. We have to avoid really what potentially could be happening when security threats are imposed upon the infrastructure in the organization. And that's been really the fundamental driver for adding network monitoring, adding security to Ironstream through the Zen technology. So Ironstream with Splunk is really about getting a 360-degree view of your entire IT systems and your entire enterprise. And we're really looking at it with a whole different paradigm than a traditional performance monitor. Much more simple infrastructure, a lot less complexity. We're collecting the mainframe data very easily by capturing that data as the system components are about to log it. We're funneling that information in a very fast manner to Splunk so that that data can be correlated very easily, analyzed, visualized within Splunk. And here's the key thing. In order to get and see this information, now that it's been exposed in Splunk via Ironstream, you don't have to give anybody access to a mainframe application. And in fact, they don't really have to have mainframe expertise to use the information. And that's critical. I mean, we're all, and I'll speak for myself, we're all getting older, those of us that have been in this mainframe world. A lot of our people are beginning to retire. We know that the universities are not putting out an abundance of talent around mainframes. And so we're going to have to do things a little bit differently. These platforms are here to stay. They are significant to organizations, but we're going to have to figure out a way to manage these platforms with, I think, a different set of people with different skills. And that's really one of the major intents around Ironstream and bringing data from Ironstream into Splunk. We've obviously added security. This isn't just about performance and availability management, which is critical, but we want to bring security information in. We want to bring syslog data in. We want to bring network data in. We want to bring everything together to enable healthier IT operations, more effective problem resolution and management. And it's all really about making the organization more operationally efficient as you take this information via Ironstream, you expose it in Splunk, and you have the capability to analyze it and use it in a more effective manner than what you've probably been doing today. So what's next? You can take an Ironstream test drive for free today. It's available on the syngsort.com website. You simply go to test drive Ironstream. You can request a demo if you'd like. We're happy to come and do that for you. If you simply want more information on Ironstream, there's an Ironstream page out there, or just contact us at info@syngsort.com. If you're already a Splunk user and you have access to the Splunk base, there are some SyncSort apps available up there. A few of the apps that I talked about today, in particular the syslog app is there, the CICS one is there. We're in the process of adding the other ones that I discussed earlier, but you're free to go to Splunk base, search on SyncSort, and get access to those applications. So that about covers the material for today. I think we have a number of different questions that have come in, and I guess I'll just start to go through those.
Great, Ed. I'll just speak them out loud so everyone can hear them. The first question is, how long does it take to have a report since an event recorded on SMF or a log?
So it's near instantaneous. I mean, I want to say it's real time. I've had arguments with folks internally that it's near real time. But in essence, when SMF is about to write that record, before it even gets written to a log data set, we capture it, we transform it, and we send it to Splunk. So within a matter of seconds, that SMF data that would have been getting logged and is still going to get logged on ZOS is available via Ironstream to Splunk.
Great. Does your syslog and or SMF logging have to be written to log streams for Ironstream to work?
No, they did not have to be written to log streams. As long as the logging of SMF, for example, is happening, right, we, again, are capturing that information in real time, in memory. So we're not pulling it from a log data set. We're actually getting an in-storage copy of that record before it would get written to a log, transforming it, and then sending it to Splunk on a TCP/IP connection. So we are not dependent upon the information being written to any log data set and capturing it from the data set. We're actually getting it prior to it getting logged to any data set or log.
Great. How much overhead does Ironstream use on ZOS or ZOS? I know some people say that. And what is done to keep ZOS overhead at a minimum?
Yeah, so again, the really great thing about the Ironstream architecture is that we're not going through a process of having the massage control blocks, pull information from unique sources. The actual collection of the information is being done by the system anyway in the form of SMF records, in the form of syslog records, whatever we're capturing. And we're literally just capturing stuff that's getting collected and is going to be written out to some source anyway. And so the minimal overhead involved, and it is really minimal, is just taking that record, transforming that information into a format so that it's recognizable by Splunk, and then over an IP connection sending it to Splunk. So very low overhead in the ZOS environment. And I'll add to that caveat, we will take and we'll offload whatever processing that we can to a zipped processor so that we're not chewing general processor engine cycles when we can offload some of that to zip.
Great. So that almost answers another question I see. Does the agent of Ironstream running on the mainframe exploit the zip engines or the general processor engines?
So can I just say yes and move on, Lauren? We never talked about that, but yeah, we do use zip technology where we can to minimize the processing that's done on a general processor.
And we have a question, can we get a copy of this presentation to share with others in my or your company? And yes, we will be sending out both the recording as well as a copy of the slide deck that Ed used so that you can share it with your colleagues. And another question I think Ed answered on the last slide is, do you provide a trial version of the software? And yes, we do that as well. So the next question is, you made a big deal of not letting people on the mainframe to keep it more secure, yet this seems to be streaming very sensitive information off platform. Once this data leaves our mainframe, how could we track that it stays secure?
Yeah, so that's a great question, right? Because we are taking mainframe data, and you know, the control point is really which data do you want Ironstream to send to Splunk. And then once it goes to Splunk, as long as you, within Splunk, give someone access to that information, they're going to be able to pretty much have exposure to it. So, so there are some capabilities within Splunk to control who gets access to what information, but fundamentally, yeah, it's like any type of information. Once you've taken it and you've exposed it, you're really going to be relegated to putting the appropriate controls around who has access to that information.
Is the job monitor for SLA app available in the Splunk apps?
It is not there today, but it will be there shortly. That is an app that will require some customization because in essence you have to run the app and trend really your job execution and tweak the setting of the thresholds. So it's not something that will is readily usable right out of the box, but it will be available there shortly.
Does Ironstream require mainframe people to be in Splunk setting it up to actually make sense of the mainframe data for the organization?
So that's a good question. I mean, the way Splunk works is information basically goes over to Splunk. It gets indexed by Splunk. And in essence, everything associated with an index is broken into very simple value data pairs. And so the information is all over there. Now, that being said, I think it still requires a little bit of mainframe expertise to understand and use that data. And so we kind of help two ways with that. First of all, we provide a guide about every record and every data field that we send over. And then the sample apps that we build and provide are ways to help organizations understand how can they use the data and how can they expose the data. So Splunk technology on its own, the base technology is really all about indexing the data, being able to search and analyze the data, visualize the data, but there is some expertise that needs to be around. Well, what is the right data to put on a dashboard, and how do we want to visualize it? And that's really where our sample apps come in, and that does require, I think, a little bit of mainframe knowledge and expertise if you're going to really want to get the most value out of it.
Is Ironstream able to port custom data tables to Splunk for analyzing?
So I think I'd want a clarification on what we mean by custom data tables. But I'll try to answer the question and guess. So today, for example, we couldn't take a custom table from DB2, although that is on the future roadmap, but we could take information that was in a flat file. We can actually today take information that's written to sysout, and we could funnel that information via Ironstream into Splunk today. So yes, with a caveat that DB2 tables are coming.
Are there any plans to support IMS log type IMS 56FA records?
Oh, that's a great question. and off the top of my head, I don't think I've heard that requirement before today. That's certainly something we can look at, but I think I'd want to have a chat with that person, probably offline, to understand better kind of what the use case would be around that.
And does the Ironstream UF support built-in Splunk load balancing? For example, can I stream the data from Ironstream to a pool of heavy forwarders to ensure log collection in the event that one of the HF is unavailable?
So I got to think about this one. This is the Ironstream. So my understanding is we are not technically a Splunk forwarder. We transport data to a Splunk forwarder, and that Splunk forwarder basically can be load balanced. So I think the answer to that question, I believe the answer to that question is yes, if I'm understanding the question correctly. So again, we are not technically a Splunk forwarder. We transport data to a Splunk forwarder, and those Splunk forwarders can be load balanced, so I'd say yes to that.
Okay, keep the questions coming. This is great. How are dashboards created and implemented in Splunk?
So the way dashboards are created and implemented, so maybe I'll go back because it'll be easier to look at an example of one of these, but bear with me here. So for example, if we take a look at the CICS transaction monitoring dashboard, what it really is comprised of is it's comprised of 4 reports. Okay, this is 4 actual unique reports in each one of these boxes. In every one of these reports is a very simple search. This one's searching on transaction rates. This one's searching on CPU usage. One's searching on transaction response time, and one's searching on failures. And when you do that search, you pretty much say, what do you want to do with the results? Do you want it to be in a graph? Do you want it to be in a table? So really simple, create the search. As part of the search, define how you want the data exposed. Save that search really as a report. In essence, you're saving a search, but you're calling it a report. And then drop that report into a dashboard. So pretty simple to do. And pretty flexible in terms of cutting and pasting information together in any manner that you want to cut and paste it together.
Does Ironstream work with ZVSC or just ZOS?
That's a great question. We do not collect VSC data today. Not sure that, well, I can tell you it's not on the short-term roadmap. That's another one we'd have to talk about, why and how if we were to do that.
What kind of historical reporting can you get from Splunk? Is data pulled from the mainframe, GDGs, or does Splunk keep its own history?
So yeah, again, we don't do anything with data sets on the ZOS mainframe. We are collecting data in memory. We are sending it directly to Splunk. Splunk has its own kind of storage infrastructure. It basically writes everything that Ironstream sends to it to its data structures, and therefore it's there for very easy historical reporting, historical trending, whatever you really want to do with it.
I think we answered this question. Does it need too much resources to manage the info of logs to show information real time? I think we answered that question previously. What filtering is available for SMF records, i.e., we may just want production kicks, not test?
Right. That's a great question. So today, the collection and the forwarding from Ironstream to Splunk is all based on SMF record type, but we are adding a filtering capability that will enable to filter on fields within records, within SMF records, and that is something that is currently in design and under development and should be launched in the first half of 2016.
Would you elaborate on the integration between Ironstream and ITSI?
Okay, so that is something that that we are just in the process of talking to our partner Splunk about. Today, the Splunk ITSI application does not include any mainframe data. So there's an essence to it about monitoring IT elements and IT components and looking at what's happening from an IT service intelligence perspective, but it's all around information that's coming from open system platforms and from web servers today. So we are right now talking about what type of technical add-on do we want to build related to the SIM model for ITSI within Splunk, and how are we going to expose the mainframe data from a visualization perspective within ITSI. So that's really something that's under development right now. That integration is being planned out. So that's something I think we'll see visualized and exposed within the Splunk ITSI, again, probably sometime in the first half of 2016.
I've read Ironstream can collect only one type of data in each instance. Would this be a separate started task for each SMF record type we are reviewing, or how can they all be put into one task? No,
so that is not a separate Ironstream task for every type of SMF record, so that's incorrect. We can collect multiple SMF record types within one instance of Ironstream and send that information to Splunk. Typically what we will have is we'll have an instance of Ironstream per LPAR, but there's not an instance of Ironstream per data type required.
Great. We look to have like about 6 or 7 questions still in the queue, so I'll read those. So folks that are still on the line, please put your questions in the chat. We've got about 10 minutes left for our time allocated. This tool looks like it needs to be installed in a server. Is that so, or how should it be installed? Which requirement server, what server requirement would we need to accomplish this?
So when it says this tool, I mean, there's really two aspects, right? Splunk aspect, which is kind of an open systems implementation that I'm not going to get into, but specifically the Ironstream technology is installed on a ZOS LPAR. It does require APF authorization in order for us to collect the types of data that we need to collect in the manner that we collect it and send that information to Splunk. So that's really all that's required of the Ironstream installation. Is there is a piece that runs on ZOS. It is an authorized piece of technology, and it's configured to talk on a port over IP to Splunk.
Follow up on the UF question. Since Ironstream is not true UF, can data be sent to a universal forwarder, or do you require a full heavy forwarder? Is there a plan to make the data stream from Ironstream to Splunk highly available?
So I'm gonna defer on the first part of the question because I don't really have the technical knowledge on that one. So we'll have to do a follow-up on who asked that question. But in terms of the second part of the question, which is a plan to make the data stream from Ironstream to Splunk highly available, yeah, that is something we're actually talking with and negotiating with Splunk on today. That's going to require some technology changes on both the Splunk and the Ironstream side. But the full intention and the strategy and direction is to make that data highly available.
Can we replace products like MXG with Ironstream?
Ooh, that's a great question. Yeah, so I hope Barry Merrill's not on. Yeah, so MXG, which is a great set of macros and reports for taking SMF data and analyzing it and displaying it within SAS, has been widely used for a long time, right? But it is still kind of batch reporting using SAS. So this is, again, it's a different model, different paradigm. This is really more about exposing data in a much more visual manner with Splunk. That being said, there's no reason that we couldn't apply and do the same kind of level of reporting in Splunk with Ironstream that is done today with MXG. That's the simple answer. I mean, obviously, MXG is pretty complex in terms of macros and everything that it does analyze. So we would have to build some of those capabilities out within Splunk. We haven't really talked about, are we going to do that? Are we going to try to replace MXG entirely? That's really never kind of been our strategy and direction. But certainly, you can make the data that you're getting today with MXG available through Ironstream to Splunk, and you can display similar types of information.
Do you plan on including RMF type reporting, i.e. CPU, paging, DASD, tape I/O, rates? I believe RESP is response, but I'm not sure if that's the
it's response time, and that's another great question. Again, RMF, and if I go back, RMF Monitor 3, I'm going to see if I can get this slide to come up. So RMF Monitor 3 data is actually getting built today. We are working basically to get the RMF Monitor 3 data real time and send that information via Ironstream to Splunk, and that will include everything that's collected by RMF Monitor 3 through the distributed data server today. So CPU data, response time data, everything that's available in those which are written actually, and we have them in the SMF, I think it's 71 to 79 records, they're available today, but those records today are only captured when at the SMF interval. And so there has been, some requirements to get that data more real time, and that's what we're going to be doing with the Monitor 3 technology that we're rolling out by the end of this year.
I may have missed the answer to this, but does Ironstream have a store and forward capability in the case the connection to Splunk is down or interrupted?
Yes, so that kind of question's kind of related to the high availability question that came up earlier. So the answer to that question today is no. We don't take and we do not, I'll back up. We have some of that today, but it's limited. And it's information that we'll keep in memory for a period of time, but we don't really store it to any type of hard data storage and forward at a later point in time. So that's part of the high availability solution that we are working on with Splunk today, and that we'll be rolling out in the near future.
Will we be able to read data from vSAN files?
The answer to that is yes, that is coming.
Does Ironstream run as a subsystem to more readily, easily intercept the data, or is it a started task?
It's a started task today. I mean, we haven't seen the need to run it as a subsystem. As we get further down the road, if that need arises, I guess we'll take a look at that, but today's just a started task.
We have 3 questions left. We have about 2 minutes. Is it reasonable to run Splunk on a mainframe, maybe a Linux IFL LPAR?
I think that's a question for Splunk that I don't want to answer. So I'm going to punt on that one.
Okay, this one should be easy. Do you have an email in which we could ask more details? So I'm just going to point the slide. You can contact us at info@syncsort.com. And then we have one last question. Would Ironstream replace a product like IBM zSecure or work together with it?
Well, I think, I'm not a big fan of competitive replacements, but this is one case where probably, you have to take a hard look at how are you using zSecure, and do we have, from your perspective, the right information to replace zSecure? And I would say yes. I mean, for all intent and purposes, we are collecting very, very similar data to what's collected by zSecure. With Splunk, you have the capability to do audits on that data. So I would say, yeah, that's a good potential replacement target.
Okay. Well, we have about a minute left, so there's still a lot of people on the webcast. So if you have any last questions, if you can type them in the chat. Otherwise, we definitely would like to thank you for coming. And again, as a reminder, all the attendees are going to receive an email in the next day or two with today's slides, as well as a link to the recording. And we hope you have a great day or evening, depending on where you called in from. And thanks, Ed, for presenting and answering the questions.
Well, thank you, Lauren. Thanks, everyone, for attending, and it's been a pleasure.